So we were talking about procedure 15. And you added ammonia, you made it basic. And then we did the ammonium sulfide, check for completeness, and I pointed out that and the only thing I wrote that here for is we were just talking about buffers. What you're doing is making a basic buffered solution there to keep the pH high enough so that you can precipitate the group 3 sulfides. And then you're adding the ammonium sulfide next. And an ideal stopping point for this procedure is right after you've done all the precipitation, because they tend to form colloids. Even when you eliminate nickel, the other things will make colloids. And if it's sitting overnight, most of those colloids separate out, so you can check for completeness. I gave you tips like adding the more concentrated ammonium acetate. We even have saturated ammonium chloride, which again is a high concentration of ions. The idea is one of them may work better than the other. So first you test with the ammonium acetate. If that doesn't help it, you might try a drop or two of the ammonium chloride saturated, not the one you use to make the buffer. It does change the buffer pH. By this time you've added almost everything you have to add and made your precipitate, so you're okay. Then procedure 16, that's where you separate the two groups. I'm just putting my own letters there, 16a, because all it does is talk about procedure 16. You're making it very basic. You separate into the two different precipitates. Then you're adding hydrogen peroxide. Key reason for hydrogen peroxide. Because if you don't get that step completed at this point, chromium will do exactly the same thing as aluminum. And when you're looking for aluminum in the confirmatory step, you'll get the precipitates of chromium. So this is the stage that gets chromium into the oxidation state where it won't interfere with the aluminum test. So if you don't complete this correctly, you get a mixture of precipitates or possibly chromium when you should be getting aluminum later on analysis scheme. That's one of the important steps. And this is a yellow-green, or greenish yellow, whichever way you want to say it. You know, it's that weird color, not chartreuse, but pea green or lime green or something like that. So it has a little bit of yellow in, whereas this one is a distinct yellow. Now the thing that makes this difficult to see, of course, is you're getting black precipitates here. You're doing all of this in the casserole, and I suggested one of the things you can do is take some of the solution out of the casserole with your pipette, put it in a clean test tube, centrifuge it, and then observe what happens to the supernatant liquid when you add hydrogen peroxide. If it's getting more yellow, that means you have to add more hydrogen peroxide to the material in the casserole. Okay. I'm just going to write one of these. This is after you added the hydrogen peroxide. There are a whole bunch of these. I gave you these the last time. But what I wanted to get to right here, this precipitate. Oh, and by the way, part of 16, remember in here, you're trying to dissolve the precipitate at the very beginning of procedure 16, and I pointed out that for your known, you have to use the aqua regia mixture. For your unknown, it's worthwhile trying to see if it dissolves in HCl, because several of my unknowns don't have anything, or only have ions that will easily be dissolved by HCl. Not having the nitric acid in there, is sort of a minor advantage. It's not going to hurt you if you put it in, but if you can avoid it, you're in better shape. Okay? So you're dissolving everything for your known. I'm going to write it as though everything were present. You have a mixture of sulfides here now. FES. If you use nitric acid, it'll be primarily this because nitric acid oxidizes to a higher oxidation state. The other thing you'll have this thing, which is black. That's why you can't see what's happening to your decantate too readily because of the hydrogen peroxide in there. You have the, which is also going to be black, and you have those. So those are the precipitates in there. Then we're going to, and this is the part I want to do, and then after I do this, I'll stop talking about it. I'll stop talking, period. "15 we did, 16 we did. And I'm on procedure 17. There we go. We're getting to procedure 17. So what you're going to do, sulfuric acid. Now these will dissolve in sulfuric acid. This will dissolve in sulfuric acid. This, you have to add some hydrogen peroxide. And in the basic solution, the hydrogen peroxide oxidizes things. In the acidic solution, it's going to reduce these to the lower oxidation state so they dissolve. The thing that confuses people about that it gives you the equations. I was going to go through the equations. You have to add them together. I guess I have to find them. There they are on page 213. In other words, he shows the hydrogen peroxide reducing this to MnO, and then he shows another step where the MnO dissolves in acid to give you Mn2+. These are equations 1130 and 1132. When I'm looking for those, I want those to be written as a single equation. In other words, you're just going to add them together. And the same thing about 31 and 33. Because the overall equation, you're not going to stop at that intermediate stage. You're just adding hydrogen peroxide and H2SO4, so it's dissolving all of those ions. So essentially, at this point, again with iron, you're going to have both oxidation states present, Fe3+, and there should be no black solid. There should be no solid. If there is, you discard it. Anytime I do that, it says you don't want to save it. Because one of the things I notice, people are saving a lot of test tubes, and they're coming up, and I want to see 8, and they've got 14 test tubes, all of which have something in it. Most of which I don't want to see because they're not part of what's proving what's there. So all of these ions should be in solution. No precipitate. The one thing you want to check, though, if you have a black precipitate, since some of these are black, you may want to try and see if the precipitate dissolves by doing an additional treatment with H2O3. Okay. So that's one of the things you can do there. Going back to the procedure then, this is the interesting thing. Lost the procedure. By the way, a lot of people have trouble with their books flopping open and closed. And now that everybody's got these cameras, what somebody did last semester, I think it was, yeah, it was just recently, last semester, they took pictures of the different procedures and sent it to themselves, and then they projected it on computer screens near where they were working, and the book wasn't flopping open and closed, and they could scan down and they could find their places on the computer screen without losing their place. Whereas when you have the book open, it sort of flops open and closed. You start procedure 17, you say all of a sudden you're adding things from procedure 19. You say, I'm not at 19 yet. Okay? So that's one of the things that people have done. I don't know if you don't do it or not, but you can certainly do something like that. So going back to this one, I'm in procedure 17. It says boil gently and boil for another minute. You're adding the hydrogen peroxide, you're dissolving the precipitate, you're adding water. The thing I wanted to remind you, people, when they boil gently, they're bringing me dry casseroles. What does that mean? You boiled too hard. You boiled all your liquid away. When you're boiling gently, you have to have liquid left when you're done. You don't want a dry casserole. Okay? And it's very easy with the flame here, because you're trying to keep your boiling water bath going and everything else. It's very easy to just evaporate all your solvent, and that's not boiling gently. Okay, so you don't want to do it that strongly. What you do is you hold your casserole way up high, and you can see when it starts bubbling a little bit, that's gentle boiling. And to keep it from going, getting hotter, you raise it up higher or something. Okay, so that's one of the things I want to do. The next thing, you're adding water. No precipitates in there. Everything should have dissolved or discarded it. And you're going to divide in 4 parts. That's the part I wanted to get to. Because this is going to be a little bit different than the procedures we did before. You're going to use one of these solutions to test for iron, and you're not going to remove the other things. It will remove itself, so to speak. And then you're going to use another test for cobalt, and another one for nickel, and another one for manganese. Now the nickel test, as I said, you don't have to do for your known, but when you do your unknown, you're going to have to follow this procedure. The reason I said you don't have to do that for the known is because you're going to do a separate test for nickel. You just want to look at the color of the precipitate. The nickel way back here is one of the things that really gives you a lot of colloidal suspension, and it's hard to get the nickel sulfide to coagulate. So we left it out. Your unknown, of course, you don't have that option. If I put nickel in there, you're going to have to deal with it. Okay? So when you're doing the drops for nickel, what you're going to do is this thing. You all remember that, right? You're going to take a fourth the number of drops, because you divided this sample into 4 parts at this point. Okay? So what you're going to do is prepare this sample, and then you're going to make the precipitate. I'll talk about the precipitate as part of the procedure later on, but that's what you're going to do with your known, so you might want to make a note of that. The other thing I wanted to do, so that you don't have this problem, I'll just say 2 plus. This is a very sensitive test. And people are always telling me that they have traces of iron, and there's no iron in my sample. Guess where your iron came from? When you're cleaning the test tube that you give me, you're scrubbing it